Hey, we're going to go through a practice problem here. It's number 18. It says find the surface area of the function x equals 1/3 y to the 3/2 minus y to the 1/2. And that's going to be rotated around the y-axis from the interval 1 to 3 in terms of y. So a couple things that we need to make sure we're good with here is we're going to use the surface area formula, which will be in terms of y. So that formula was 2 pi times the integral from the endpoints a to b of the function g of y times the square root of 1 plus g prime squared dy. So remember, that's basically a circumference times a little hypotenuse revolution there. So the things we need are g prime, which was our given function, 1/3 y to the 3/2 minus y to the 1/2. And we also need to take the derivative of g and then square it. So derivative using the power rule and then squaring it will be 1/4 y minus 1/2 plus 1/4 y to the negative 1. So we're going to take that function, the original function given, and the square part of it, and plug it into that formula I just gave you. And when it's all plugged in, we'll have 2 pi from endpoints 1 to 3, which we're given, of the function 1/3 y to the 3/2 minus y to the 1/2, and all that's times the square root of 1 plus what we just found, 1/4 y minus 1/2 plus 1/4 y to the negative 1, and all that will be integrated in terms of y. So I'm going to, under the square root, add that 1 in, and it gives me a perfect square. Okay, so what's left under my square root is a perfect square, so I can take the square root of it. At that point, I have 2 pi times the integral from 1 to 3 of my original function, 1/3 y to the 3/2 minus y to the 1/2, and times the result of that square root, which was 1/2 y to the 1/2 plus 1/2 y to the negative 1/2. Okay, so at that point, let's slide down a little bit. I've got two big binomials. I need to fold them together, and in folding it, there are some like terms I need to combine. And the last thing I have before I integrate is the function 2 pi from 1 to 3 of 1/6 y squared minus 1/3 y minus 1/2 dy. So I'll integrate. And this one's pretty simple because I'm just reversing the power rule a couple times. But I'll get 2 pi times the quantity of 1/18 y cubed minus 1/6 y squared minus 1/2 y integrated from 1 to 3. And then I'm going to plug in those values. I'm going to plug in y of 3 and y of 1. And when I do everything, I end up with the total, which is supposed to be surface area, of negative 16 pi over 9. That may seem a little bit troublesome to you at first, and it should make you ask some questions. So if we get a surface area that's a negative number, that doesn't make a lot of sense. Well, let's look at the graph just to kind of explain what happened here. And remember, we were integrating in terms of y. Okay? And here I have the graph, and this y section, if you think about above, below, usually we think about in terms of x, there's an above and below when we're totaling up things. But here, since we're integrating in terms of y, the x for the positive is positive and the x for the negative is negative. So it's over here on the negative side. Okay? So these are all negative x values, and when they get added together, it kind of messes things up, because if you think about where the y-axis is, those are below the y-axis. Okay. So in actuality, we got the right number, but it should be 16 pi over 9.